All right, hopefully it comes as no surprise, but Lab 14, we're going to do a binary search tree. Of course, we're going to template it. I've given you some boilerplate code to begin with. This should hopefully be straightforward. I gave you some helper functions just to get you started in case you wanted to do it recursively with put. In this lab, add is called put, and we have something called in-order string, which we will get to in a moment. But the idea is here you need to implement the empty constructor, the copy constructor, we talked about that, put, aka add, in-order string, and lowest common ancestor, and deconstructor. I believe there's also a contains in here. We'll get to each one of them. So constructor, and just like in our class, copy constructor, we didn't do that, but it must become a copy of the tree. Please put it in the same location, so do a pre-order addition or traversal while you add. Add a given value to the binary tree, must maintain ordering, do not do any balancing. I did not talk about balancing because I want to make sure you don't do it. When people look up resources on this, they may start looking at how to balance the binary tree. Don't do that. You'll get giant headaches. Just do put, kind of like how we did in class. Height returns the height of the binary tree. Let's see, in order string. So, all right, this can be a little tricky because C++ loves to mix this up all the time. But this is what's going on. If you have a tree of 4, 1, 10, in order string needs to return a string in the order 1, 4, 10, and then a space. Put the extra space there because that'll make your life easy. Because if you need to print something to the in-order string, print the number and then a space afterwards. That way you don't have to call .trim or something crazy like that. Just do it this way. I'm trying to make it easy. What can be difficult is how do you convert an integer to a string using concatenation. In C, I think you make a string stream. So there is an IO stream, make a string stream, and then you add it to that. Yeah. Whatever. All right. Next one, return the lowest common ancestor of two values. Unfortunately, this PDF did not print it out too well, so let me jump over to the code. Here we go. So your binary tree's here, 4, here's a 2 over here, a 1, 3, 8, 6, and 10. So the lowest common ancestor of 1 and 3, aka the lowest common ancestor of 1 and 3 is 2. 4 is not the lowest because 2 is lower. Lowest common ancestor of 1 and 2 is 2. We'll say that you are your own ancestor. Congratulations. Lowest common ancestor of 1 and 6 is 4, because 2 is not an ancestor of 6, and 8 is not an ancestor of 1, so lowest common ancestor is 4. This is a little bit of a puzzle, but think of it recursively, and hopefully it'll pop out. This is a good example of practice for binary trees. I mean, you can do the iterative one if you really want to as well, sure. And we didn't free any of our memory. Make sure you do that. Excuse me. Again, using one of the traversals will probably be very helpful. Keep in mind that if you're traversing after you delete it, you don't want to traverse the node. So hopefully that narrows down which traversal you should use. All right, and let's see. I think that's it. I don't have a contains function. It's amazing. All right. Due 1 week from today. Any questions? Comments? Screams?
This might be the week for it.
All right, maybe next week. Next week, okay. All right.
I doubt it.
I doubt it. Oh, it's this week? All right. Well,
maybe Monday.
Maybe Monday? Okay. All right, Monday. All right, guys, that is all for today. Definitely get started on Project 2 if you haven't already, and I will be online to answer questions, especially Monday. Have a good week.